All right, on tonight's episode of Python Papi, we're back inside our artificial intelligence course, and we're still inside our natural language module. Let's have a look at what we went over tonight. Now, we still haven't gotten around to writing any code as of yet. We're still going over certain concepts we need to understand before we can move forward. So tonight is going to be some light reading again, and let's pick up where we left off. So rather than treat this review as a string of a sequence of words in order, we're just going to treat it as an unordered collection of words. We're going to try to calculate the probability that the review is positive, given that all of the words in our review are in the review in no particular order, just an unordered collection of words. Basically saying we don't really care what order the words are in, just as long as all of the words are in the review. And this is a conditional probability, which we can then apply Bayes' rule to try and make sense of. So according to Bayes' rule, this conditional probability is equal to the probability that all of the words were in the review, given the review is positive, multiplied by the probability that the review is positive, divided by the probability that all of these words happen to be in the review. I know that sounds like a mouthful, but just stick with me. So we have that here. This is the probability that the sentiment is positive, given that all of these words are in the review. And that's equal to the probability that the sentiment is positive, given that all of the words were in the review, given that the sentiment is positive, multiplied by the probability of the sentiment being positive, divided by the probability that all of the words are in the review. Now, this is the value that we're trying to calculate. And one thing we might notice is that the denominator, the probability that all of the words appear in the review, doesn't actually happen or doesn't actually depend on whether or not we're looking at the positive sentiment or negative sentiment case. Let me show you that really quickly. So you can see here, this is our denominator. You can just see it's the probability that all of these words appear in the review. Unlike the numerator, where it's the probability based on the sentiment being positive, given that all of the words in the review. So we could actually get rid of the denominator because we don't need to calculate it. We could just say that the first probability, see line 657, is proportional to the numerator, see line 663. So I showed you the numerator. I showed you the numerator already. This is our first probability here. Probability that the sentiment is positive, given that all of the words are in the review. And then this is the numerator here, the probability that the sentiment is positive, given that all of the words are in the review, given that the sentiment is positive, multiplied by the probability of the sentiment being positive. Yeah, so we're only going to work with these two, the numerator and the first probability. So we're actually going to drop the denominator. I don't know why I wrote it out. I just wrote it out so we can follow along better. And in the end, we're going to need to normalize the probability distribution to make sure that all of the values sum up to the value 1. So now, how do we calculate this value? This is the probability of all of these words given positive times the probability of positive. And that, by the definition of joint probability, is just one big joint probability. The probability that all of these things are the case, that it's a positive review and all of the words in the review. But still, it's not entirely obvious how we calculate the value. And here's where we need to make one more assumption. This is where the naive part of our naive Bayes come in. We're going to make the assumption that all of the words are independent of each other. And by that, we mean that if the word Gates is in a review, that doesn't change the probability that the word family is in a review or the word Disney is in a review, for example. And in practice, this assumption might not be true. It's almost certainly the case that the probability of words do depend on each other, though. But it's going to simplify our analysis and still give us reasonable good results. Just assume that the words are independent of each other and they only depend on whether it's positive or negative. I'm going to leave it there for a night. We did a lot more note taking. We dove even deeper into taking the examples and writing down those models. But again, it'll just have you spinning in circles, trying to give you everything from the top without giving you an entire breakdown. So yeah, you're gonna leave it there for the night. But of course, I will pick it back up for you tomorrow. And I'm pretty sure we're gonna be running code tomorrow. If we're not, then it's gonna be the day after. But I'm pretty sure it should be tomorrow. So yeah, we're gonna be doing some interesting things tomorrow. But of course, I will keep you posted every step of the way. For now, this is the Python Poppy. You guys stay Gucci.